Hello everyone, welcome to my channel. Today let us learn the topic number system. Before going into the topic, let us have introduction to this topic. There are different kinds of number system, like different types of numbers. Natural numbers, which starts from 1 and are positive, 1, 2, 3, 4, so on up to infinite. Whole numbers, which are natural numbers plus 0, like for example they start from 0 and 1, 2, 3, and so on. Integers are the whole numbers and their negative counterparts like 1 minus 1, 2 minus 2, 3 minus 3, and so on up to positive infinity and negative infinity including 0. And each set of numbers are represented by a letter n for natural numbers, w whole numbers, z for integers, and so on. Next is rational numbers, which is represented by q. The numbers expressible as a fraction like p by q, where q is not equal to 0 in any case. And irrational numbers, the numbers that cannot be expressed as simple fractions such as pi or root 2 and so on. Real numbers. Real numbers is the set of all rational and irrational numbers combined together. Now, coming to the types of number systems. There are many kinds of number systems, some of which are decimal base 10, which is commonly used across the world. Like the numbers, base numbers are 0, 1, 2, 3, so on up to 9, and the cycle repeat. Next is binary, which is base 2, 0, 1, which is mainly used in computer programming and coding. Next is octal, which is base 8. The numbers start from 0 to 7 and the cycle repeats. The next is hexadecimal numbers. The base is 16. That is from 0 to 9 and A to F, A, B, C, D, E, F. These 6 numbers are also forms the part of the hexadecimal number. The Roman numbers. Roman numbers are completely alphabetical numbers. In different number systems, the digit has its positional value. Like, so for example, the 5 in 50 and 500, it has a different value. Like only 5, its value is 5, and 50 means its value increased 10 times, and 500 its value increased 100 times depending upon its position. And here in the same case for 2 also, 42 and 24, the value is here 2 and here is 20. So these kind of positional values digits will have. And in some number systems, the positional values are immaterial. Like for example, in Roman numbers, the value of that particular Roman number does not change by the position of the number. Now let us try to learn some of the concepts like LCM and HCF or GCD. What is LCM? LCM, the full form is least common multiple. GCD, the full form is greatest common divisor, and HCF, the full form is highest common factor. Both are these are same, just the representation changes. What is LCM actually? LCM is the smallest positive integer that is divisible by each of the given numbers. Say for example, a set of numbers is given. What is the smallest positive integer with which each and every number is divisible? And what is HCF? HCF, the full form is highest common factor. That means the greatest number that divides two or more integers without a remainder. Here remember one thing, HCF is always less than or equal to the given set of numbers. That is the highest value. HCF may be the lowest or the least number in the set. And LCM is always greater than or equal to the given set of numbers. Like for example, LCM may be the highest or the greatest number in the given set. To understand these statements, let us try to have some examples. Let us take first set of numbers 2, 3 and 6. The LCM of these three numbers is 6. Like 6 is the common multiple for 2, 3 and 6 also. And the next set 6, 12 and 18. Here 18 is not the least common multiple because 12 cannot divide 18 with the remainder 0. So the LCM is not 18. Now recall the statement, LCM may be the highest or the greatest number in the given set. Maybe. Suppose in this example, LCM is the highest number, but in this example, LCM is not the highest number of the set. So this statement can be understood in these examples. And to understand the statement regarding HCF, HCF of 6 and 12 is 6. This is the least number in the given set. And HCF of 8 and 12 is not 8 because 8 is not the factor of 12. So 8 is not the HCF of these two given sets. So from these statements, the conclusion is HCF is always less than or equal to LCM. Generally, equal to never happens for a given set of unique numbers. This you just keep it in mind. So the conclusion is HCF is always less than LCM. And remember one thing, don't get confused by the name HCF, that is highest common factor and least common multiple, because highest common factor is always less than the least common multiple, that is LCM. See, here you may get confused that this is least, so this is the lower number, this is highest, this is the higher number. That doesn't go. Now, to find out the HCF and LCM of given set of numbers, if the number's size is very small, you can find the HCF and LCM of that set very easily. But if the numbers or the number size increases, then finding it becomes very difficult. For that, there are some methods to find HCF and LCM. First one is prime factorization method. Now, first, if any two numbers are given, list out all the prime factors of each of the given numbers. Now, the LCM is the product of highest power of all the prime factors, and the HCF is the product of lowest power of each of the common factor. This, just remember this word, common factor. And in case for LCM, it is all the prime factors and not the common factors. And the second method is division method, that is Euclidean algorithm for HCF. Divide the larger number by the smaller number, then divide the divisor by the remainder until the remainder is 0. The last non-zero divisor is the HCF. And the other method is ladder method. Divide the numbers by common factors until they are co-prime to find the HCF, and continue till 1 to find the LCM. And a very useful point for competitive exams is the product of two numbers, only two numbers, is HCF and LCM multiplication together. That is LCM of A comma B into HCF of A comma B is equal to A into B. This relationship is applicable for only two numbers and may not be true for three or more numbers. It can be true or it cannot be true, but for this category, like only two numbers, the LCM into HCF, the product is equal to the product of the two numbers itself. This is always true. If you are able to find LCM of the numbers and if you are unable to find the HCF or vice versa, you can directly do this formula and get the number. Let us try to understand the concept more easily by using some examples. Example 1. Find the LCM and HCF of 12 and 8. There are some methods we already discussed. That is one prime factorization method. What are the prime factors of 12? 2 into 2 into 3, that is 2 square into 3 power 1. And for 18 it is 2 into 3 into 3, that is 2 power 1 into 3 square. As we all know, HCF is the lowest power of common factors, that is 2 power 1 into 3 power 1, so that is 6. And LCM is the highest power of all the factors, like 2 square into 3 square, that is 2 square into 3 square, that is 4 into 9, that is 36. Now to cross verify this thing, this formula, like LCM into HCF is equal to product of the numbers, we will apply here and see. The product of the numbers 12 into 18 is equal to 216, and LCM into HCF is equal to 6 into 36, that is 216. So this formula is true in this case. And there are some other statements which we had discussed earlier, that is HCF is always less than LCM, and HCF is always less than or equal to the least number of the set, and LCM is always greater than or equal to the highest number in the set. So all these three are true in this case. Now let us try to solve one more example. Find the LCM and HCF of 24 and 15. First we find LCM. 24 can be written as 2 into 12, 2 into 2 into 6. This is prime factorization method. 2 into 2 into 6, 2 into 2 into 2 into 3. And so the final is 2 power 3 into 3 power 1. And for the 15, it can be written as 3 into 5. So now the LCM is highest power of all the prime factors. It is 2 power 3 into 3 power 1 into 5 power 1. And remember one thing, if there is any common prime factor, you have to take the highest power only once, not that you have to take it each and every time. So here 3 power 1 into 5 power 1, that is 120. So the LCM of 24 and 15 is 120, and HCF is the lowest power of the common factors, that is 3 power 1. This is the only common factor, so this is 3. And there are some gist of the tips we have already discussed. Like LCM into HCF is equal to the product of two numbers. Like if you find LCM, then HCF is equal to LCM by two product of two numbers. Or if you find LCM, then LCM is equal to HCF by product of two numbers. And for fractions, how do you calculate LCM and HCF of the fractions? For LCM of the fractions is equal to LCM of numerators by HCF of denominators, and HCF of the fractions is equal to HCF of the numerators by LCM of the denominators. So this way you can find the fractions LCM and HCF also. What are the basic applications where this HCF and LCM are used? HCF is used like to split the items into smaller equal parts. Like for example, if there is any room size given, finding the largest tile size for a floor of that particular room, and so on. Like LCM is used to determine when the events will occur repeatedly or coincidentally. Like for example, if runners are meeting at the same time on a track, or the planets revolving around the sun are meeting at the exact linear line, when does this occur? So to determine all these things, HCF and LCM can be used. It is not only just for the calculation purposes. Hope you understood the topic clearly. Thanks for watching, and please subscribe channel for more such content.